All right, so chapter 10 is going to be dealing with circles. Okay, pretty much all things circles all the time. So the previous chapters we were doing triangles. Pretty much every shape can get broken down to a triangle. That's why we focus so much on that one. The only shapes that really can't get broken down into triangles are going to be circles. So that's why we're going to spend this this last full chapter that we'll do. And even then, it might not be like the full chapter. It's going to be on circles. Okay. All right, so the objectives for the lesson. You'll be able to identify and use parts of circles. Okay, we're going to have a good chunk of brand new terms that we have not talked about yet. So you have some vocabulary that will be new to this lesson in this chapter. And then you guys will be able to solve problems that use the circumference of a circle. So we've already done the circumference and area of a circle before Christmas break. It's been quite a while. So we'll kind of get to that one towards the end of the lesson today. But again, lots of definitions for the first part. And then after this, we'll be able to go from there. Okay? The official definition of a circle. It is a set of all points in a plane that are all an equal distance from the center point of the circle. Or from the center, and that's going to be the circle itself. So every single spot here is going to be the exact same distance away from that central point. Yes, ma'am.
Are we doing notes today?
No, you'll have an assignment at the end. But realistically, it's a pretty quick lesson for today. Quick assignment for today. Okay, one other thing, you guys have the definition written down, is the way that we identify circles, the way that we're going to call them the names that they are. The central point, so like this point in here, this is going to be point C. This will be circle C. Does that make sense? So from this central point, you'll kind of have the circle around it. This will be circle C, this will be circle A. That's going to be how we identify it. There really isn't a great way to give it different names. Like when we had triangles, it would be like triangle ABC. Okay, or rectangle, it would be rectangle ABCD. Like if you give 3 separate letters for each one of the points. Because it's a circle, they really don't have points on the outside because it's all one giant line. Because of that, that's how we're going to label it. Is going to be call it circle C, or we have like a little circle with a dot and then the letter behind it. This is circle A, or that circle with a dot and the letter A. So when you see that, that is how it is described or labeled. All right, good. Okay, here are the 3 extra words we have. 2 of them should be ones you've seen before. We've got a brand new one that's going to be called chord. So I'll zoom into the definitions and then I'll show you my picture a little bit better. Really identify this part. So these are all segments or special segments that are all inside of a circle. I'm going to write this or kind of highlight that part. There will be a later section that deals with stuff that happens outside of the circle. All of this stuff happens inside of the circle. Okay? So the radius, it goes from the very center, and it has an end point on the outside of the circle. So it starts in the center, and it goes to the outside. So like CE, CF, CD. Go from the center to the outside. All right, I'm going to skip down to the third definition. The diameter, so hopefully you guys have all had that one before. That one goes from one side of the circle all the way to the other side of the circle, and it cuts through the center of the circle. Okay? The fancy definition means that they are collinear, means that they're both in the exact same line. So it's going to be a straight line that goes through the center, and it touches both outside edges of a circle. All right, and the very last definition is going to be called a chord. A chord is going to be a line segment that is completely within the circle itself. It starts and ends on the sides of the circle. So like AB is going to be a chord. It starts on the side of a circle, and it goes on the, again, another side of the circle. But you got two endpoints on that exact same circle. So AB is a chord. Okay, DE, even though it is a diameter, it still is a chord. It starts on the edge of the circle, and it ends on the edge of the circle. Okay, but it has to start and end on the sides of the circle itself. And every single one of these is all within the circle itself. Okay, nothing's going outside of it. Okay, I kind of pointed that out in that top one, but I wanted to give you the definition. So again, that same picture that was there, or not the exact same picture, but again, the diameter just goes from the chord, it goes through both sides. You got radius, you're going to have the chords themselves. Don't worry about this thing here. I had another name for it. All right, so we're going to have a chance to do a little bit of practice with some circles. The stuff you'll have, we're going to name the circle. I'm going to make some little notes on the board so that way you can kind of remember it. Okay, when we name a circle, it's going to be that circle with a dot, and then whatever the letter is. So this very central point, that's going to be how we name the circle. Okay, a radius goes from the center to one of those outsides. So no matter what, the radius is going to have that letter. That's part of it. And then we're going to deal with chords and then diameters. So again, lots of stuff is going on in this picture. I'll give you a chance to draw it if you'd like, and then we will talk it. All right, so again, lots of stuff is happening in the circle. On the assignment today, I'm not going to expect you guys to name every single one of them. So as the example already starts, it says name the circle, name a chord, meaning one, and a diameter of the circle. So a radius, a chord, a diameter. Meaning I just want at least one of them. There's going to be more than one, but you really only need to answer one of those for me. So I'll start off with this one. The name of the circle. Okay, we're going to find the very central point. So the name of the circle is going to be circle X. Okay, we're finding that very central point of the circle itself. It's going to be identified by the circle with a little dot on the inside of it. And that's going to be X. The reason we give the extra dot on the inside of it is otherwise it looks like either the number 0 or the letter O. Okay, so we're going to give that extra dot on the inside of it just to make sure that we can verify that it is one of those. For the radius, because it's going to be circle X, the radius, no matter what, will have the letter X that's part of it. So this one has 4 separate radiuses, radii. Okay, so it could be XV. It could be the line segment XT. It could be XU. Or it could be XZ. Again, it does not have to be all of those, but it could be any one of those 4 when it comes time for identifying what a radius is. The reason we need to know what a radius is that if we know the length of this one, we will also know the length of this, this, and this. Because again, from the center to the outside, they're all equidistant, meaning that if you can get this, you'll get every single one of those radii. Okay? If you can get the diameter, I'm going to skip down to the diameter as my next one. Because again, diameter is 2 different radii put together. So for the diameter, it has to go through the center. The only one we have for a diameter is going to be this one that goes from one side to the other side. And when we write it, we do not write that central letter, because if we threw X in there, it'd make it look like it was an angle. So line segments only are going to have 2 letters, and they're going to have the line over the top. So line segments have to have the 2 letters, line over the top. If you have more than 2 letters, it's going to be an angle, so it's not going to be the same thing. And if you give me just 1 letter, it's only a point. All right, the very last one that I'm going to do is going to be chords. Chords are going to start and end on the sides of the circle. So this circle has 2 chords. We could have RS, because that one starts and ends on 2 sides of that circle. The other chord that we have, let me erase that so it doesn't confuse you. Maybe if it'll go, there we go. The other chord that we have, it's also a diameter, but ZT is also a chord. Again, a lot of stuff that's going on in there, but from that one picture, we've got a lot of pieces of information that we can work with. So far, so good? Okay, this one you're going to help me out. I'm not going to make you do all of them, but here's the next circle we have. You can write it if you'd like. This is the one where you guys tell me all my answers. All right, first part, the circle. What's the name? Mary Grace? Perfect. So we're going to call it circle. So circle with a dot and the letter E. Fantastic. Next one, I want to know a radius. Give me one radius from the circle.
Yeah.
Which one?
Yeah.
EF, yeah. I thought you said EI, and I was real confused for a second. So EF. Okay, that one, the one start from the circle, went to the outside. If you have a different one?
Yeah, EH.
Perfect. Yeah, I'm not looking for all, or on the assignment, I'm not going to look for all of them, but for the practice, I'm going to. There's one more. Brady? EG, fantastic. Perfect. All right, next one. I'm going to jump down to the diameter, and then I'll do chords. Diameter. Mary Grace?
HG.
Perfect. HG. Starts here, goes all the way across, and cuts back across. Diameter of the circle. Fantastic. The very last one, I'm going to do chords. Just kidding. JK? I got one more. No. HG. Okay, I got an H and G. Even though it is also the diameter, it's also going to be a chord because it starts and ends on the sides of the circle. Okay, if I'm going to kind of stick along with that one, if they were to draw a little line that connected these ones, even though it's super duper short, this would be a chord as well. Okay, it would be KG, that could be a chord, but again, they have to draw the line in between it. It doesn't mean it has to go a long ways across the circle. It can be as short as this. It could be like as short as those two. Okay, a chord is just going to start and end on the sides of the circle. All right, I'm going to give you one more, and then you guys are going to do that one on your own. Again, not perfect circle, but you get the idea. Ooh. I want you guys to do at least one of each type. I come by just double checking that you guys got it. All right, I like what I'm seeing, guys. Seems like this one is clicking. It should be a Nice easy one for today. So the name of the circle for this one, you guys all wrote it perfectly. Again, that circle with the dot, M. Your radius, there's going to be 3 of them. You didn't have to do all of them, but you could have had M, P, M, N, or M, O. Diameter would have been PO or OP. The order did not matter. And then your chords could have been QO or PO, either one of those. You guys got it? Feeling good? Perfect. Okay, this stuff, I'm not going to spend a ton of time on it because I feel like you guys have this from previous years. But if you want to write it down, you can. Here's the relationship between the radius and the diameter. So if they give you the radius, the diameter is twice as big. It's 2 of them put together. If they give you the diameter, you divide it by 2. It's really all the same. All right, so a lot of these ones are going to start off with story problem-ish. Whoops. You guys already have the answer, my bad. It's saying that TU, is going to be, you have this picture, is 14 feet. So when they give you this circle, you will need to write down those pieces there. TU is going to be 14 feet. As I look at that circle, does it go from one side of the circle to the other side? Yes. Does it go through the center? Yes. If it's doing all 3 of those things, or 2 of those things, one side or the other side, and goes to the center, it is a true diameter. Okay, if it doesn't go through the center, it's just a chord. It wouldn't count as a diameter, and we wouldn't be able to have a solution. But this one does all of those. It starts on one side, ends on the other side. It goes to the center. It's 14 feet. So if we need to find the radius of that, it's giving us the diameter. Fantastic. 14 divided by 2, which means that my radius is going to be 7. Feeling pretty good on that stuff? Okay. You're going to have some that look like this. They're not going to tell you the information. Okay. Sorry. There should be a circle that went with it. I don't know where I might have accidentally deleted it. Okay. This one looked like this. It had the circle Q. Oh, sorry. We're using this one up top. That's what it was. Whoops. Use that same circle. Let me get rid of that part. I'll just redraw it down here. Like this. Q was in the center. I had V. I had T. I had U. So T, V. Here's a Q. And then down here is going to be the U. It's saying that QT is 11 meters. This distance from there to there. What's the distance for QU? 11. How'd you figure out 11? You're right. Yeah, this is a radius. This is a radius. This is also a radius. If you can figure out one of them, you figured out every other radius. Again, the first lesson should be a real quick, easy one. Hopefully we're not going to have too many brain busters in here. Okay, so I've got my next circle here. Again, circle V. I've got R, V, and T. Those are all in a straight line. Those are all collinear, with RT being a diameter. And I've got S, V, and Q, all collinear. That one's also a diameter. Let you write it down, and then I will draw the pictures, and we'll talk about it. All right, so this one says RT is 21 centimeters. That means that this length from here all the way down to there is 21 centimeters. Okay, that R all the way to T, what's another name for that? Diameter, perfect. So if I know the diameter is going to be 21, and it wants me to find, let me get a different color pen here. Oh, heck, I'll use a highlighter. It wants me to find QV, this segment right here. Is that a diameter or is that a radius? Radius. So if they give you the diameter, they want you to find the radius. How can we find that distance? Perfect. 21 divided by 2. If I do that, I get 10.5. So QV at this point is going to equal 10.5. Again, you can figure out one diameter. You can figure out the rest of the diameters and all the radius. You all okay? Yep. Super. Okay. These last, again, it's a lot of information, so I wanted to make sure I go through all that stuff. Seems kind of, I'm going to say scary-ish, but not too bad. Okay. This next one's going to be what's referred to as circle pairs. Okay. The way it's works is before we had triangles, and you had to figure out like side, angle, angle, all that sort of stuff to figure out if circles are going to be congruent. Okay? Or sorry, if triangles were congruent. The great thing about circles is that circles, no matter what, they always go completely around. So, if we can go through and we figure out that every single circle is going to have the exact same formula to solve the distance of it, again, that diameter times the radius, or diameter times pi, or 2 times the radius times pi. If they're all going to follow that exact same formula, that tells me that the distance between these segments on 2 circles are going to be similar because the circles are similar. So that means the ratios are going to work the same way. Okay, every single circle is going to be similar because they're all circles. Yeah, you don't have a fancy circle that only has 370 degrees, or has exactly 370. Every circle is going to be 360. That's what they always add up to. Okay, so if circles are similar, that means that they'll always have congruent radii. Okay, that also means that concentric circles are going to be similar. Concentric circles are going to have the exact same center radius, the center point, but they're going to have different length radii. Did you guys feel good when I talked about triangles in the previous chapter and how we can figure out that they're similar? Okay, then I'm not going to spend a bunch of time showing that correlation between triangles and that sort of stuff. Okay? Sorry, did anybody need more time? Apologize. Ignore the drawings underneath it. All right. I'm gonna jump into the definition of concentric circles. When we have straight lines that are never ever gonna touch, what do we call those ones? Starts with a P. Like if I had two lines that looked like, yeah. So if they're straight lines, we call them parallel. If they're going to be within circles or within shapes, that's going to be what's referred to as concentric circles, meaning the sides aren't going to touch each other. They're going to either expand or contract all at the exact same rate. So we dealt parallel lines, dealt with straight lines. Concentric circles are going to deal with, concentric lines are going to deal usually with circles all getting bigger or smaller, but they'll never touch each other. Okay? Oop, I didn't erase this stuff, my bad. All right. We'll do this one, and then I'm going to give you a little bit of work time, and then I'll do the very last part together. Okay. It's a lot of stuff, but again, as long as we know that there are going to be similarities between the circles and the shapes, we can compare a lot of that information. Okay, so the first one says the diameter of circle X is 22 units. Diameter of circle Y is 16 units, and WZ is 5. It wants me to find the distance between X and Y. A lot of information there. We'll be able to start to break it down. Okay, I'm going to do this just so I don't have to confuse you with some other stuff that's going through. So here's a diameter. The diameter of this first circle is 22 units long. If the diameter is 22, what is the radius? 11. Okay, so I know that the distance from here all the way to here is going to be 11. So that distance is 11. It's saying the diameter of circle Y, I'll draw that line here, is 16 units. So what would the radius of circle Y be? 8, because you just divided it by 2. That means that this distance here is going to be 8. Here, I'm just going to, you guys have those numbers. I'm going to erase the other radius stuff so it's not, or the diameter stuff so it's not as overwhelming for you. Okay, you guys figured out the radius right away. So I'm going to be able to zoom in on this. It said the distance for WZ is 5 units. Okay? I've got all this information. It wants me to be able to figure out the total distance between this point and this point. Based on this information here, this distance is 11, this distance is 8, this little spot between here and here is 5. How could we figure out the distance between here and here? So, not quite. I'm going to jump back a couple lessons. Without the circles, without trying to confuse you as much. So I've got this thing here. I've got this thing here. This distance here is 11. This distance here is 8. This one is 5. Okay? So I'm going to pull out my highlighters here because I do love me some highlighters. That means this entire distance, this whole entire thing here is going to be 8. Do we care about this 11 right now? No. I'm going to cover it up. So this whole length is 8. This part is 5. How can I figure out just that small length?
8 minus 5.
8 minus 5. I can just do subtraction. So 8 minus 5, that tells me that this length right here is 3. Whoops. Let me get my pen again. Not a highlighter. Because again, if this is 5, this is 3, that adds up to 8. If I do the same thing on the bottom, here's 5. How long would this section be? 6, because you did 11 minus 5. This one was 6. Without those extra circles around it, you guys did that no problem. So the total length from this side over here all the way to here, I'm just going to either add up all these segments, or I can do the full segment plus that 3 just to get the full distance. So how long is it from side to side? 14. I got 6 plus 5 plus 3. That total length from here all the way to there is going to be 14. Again, I did it without having circles around it, but it's the same thing. This one would be that 3. The distance between here and here would be that 6. So the distance for x, y, that whole entire length, is we would just add up every single one of those line segments, and we get xy is going to equal 14. Feeling okay? If it gets way too confusing with the circles that are going around and all this other stuff, and you just get overwhelmed, feel free to just make that straight line like I did in the bottom. Okay? This will be kind of the same thing. So I'll have you guys talk me through it, and then I'll let you guys do a chance to make it work. All right, you guys talk me through it. Diameter of circle S is 30 units. So what's the radius of circle S? 15. You guys got that part down. So this distance here to here is 15. The diameter of circle R is 20 units. What's the radius? 10. You got it. Okay. Now it's saying that DS is 9 units long. So this spot right here is 9 units long. The things it wants me to find are going to be CD and then RC. So let's look real close. I'm going to zoom in on that part. I've got this total length of 15. This one's 9. How can I figure out the distance between C and D? Just subtract it. So I'm going to take 15 minus 9. What do you get? 6. So the length of CD is going to be 6. Now that I know CD is 6, what's the distance for RC? 4. You took 10 minus 6. So the distance for RC is going to be 4. Again, looks big, looks scary. Not too bad, hopefully. Yeah? Okay. Do you guys remember this formula? By a show of hands, who does not remember this formula? Okay. The formula is going to be, for circumference, is going to be pi times the diameter. Or 2 times pi times the radius, because that's what it is. I'm not going to go... I'm not going to go too crazy on this stuff. You guys can put that stuff into the formulas. I'm not going to go too crazy on it because I think you guys still have that from that chapter way at the beginning of the year. Okay? So I'm not going to go crazy. Homework, page 701 then. You guys have 25 minutes, 24 minutes? It's going to be page 701, 1 through 6. Those first ones that you'll do. First ones you're going to do, you're just going to be identifying the parts. You'll do all 6, but you're just going to identify a chord a diameter, a radius. That means you only need to do one of them. Okay. So that's what you're looking for on those ones. Numbers 10 through 32 will be a little bit more of naming it, and then a little bit of the algebra stuff with numbers 28 through 32 even. You'll be doing what?